This is a DC circuit with a DC voltage source V1 providing 120 volt, two resistors R1 and R2, and a DC current source I1 set to provide a constant current of 3 ampere. V1 connected in series with resistor 1 R1, a resistor whose value we need to reduce a voltage drop of 120 volt is observed across R1 and the current through R1 is 2.118 ampere. Using Ohm's law, the value R1 can be calculated. R1 equals to V over I, and we got the value of R1 is 56.7 ohms. R2 has a resistance of 14 and has a current of 3.118 ampere passing through it. The voltage drop across R2 can be calculated as V equals to IR. We got the value of V resistor 2 is 43.65 volt. The current source I1 is set to 3 ampere. This current source provides current in the same direction as the current through R2. The voltage at the node between R1 and R2 is around 113.8 volt relative to ground. The ground point is set at 0 volt as the reference. The first image shows a DC circuit diagram with a 120 volt DC source, a 10 ohm resistor, and a 1N4148 diode. If the diode becomes forward biased, the high voltage would cause a current about 11.93 ampere, which is far between the diode safe limit of around 300 milliampere, potentially damage it. The second image is simulation of current versus voltage graph. Illustrate how the diode current remains low until it reaches around 0.7 volt, after which it rises sharply. Together, this image shows that in these circuits, forward biasing the diode could lead to dangerous high current and potentially diode fail.
Assalamualaikum. My name is Arif Iskandar. So I will explain about this part. This part is about AC sweep. So AC sweep is a simulation that examines how a circuit's output voltage and current respond to different frequency. So this allows you to examine how the output voltage or current throughout the circuit respond to different driving frequency. Okay, so I will we must do the simulation do the simulation at PSpice software. So we just follow this instruction to get the result like this graph. Okay, so I will show the simulation and the simulation result. Okay, so this our AC sweep simulation in PSpice simulation. So this the circuits that design to AC sweep. So I will show you the graph. Okay, so this is our AC sweep graph after the simulation. So we get the graph is frequency over to voltage. Okay, so this is the bandwidth. Okay, so that's all from this part, AC suite. Okay, in this part, time domain transient, so I will explain the about this simulation time domain transient. So this part we just follow the instruction to get the perfect simulation, just like in the lab sheet show. Okay, so I will show you the simulation at the Pispice software. Okay, so this is our time domain transition simulation. So after we run the simulation, we get the voltage in diode 100 193.2 volt, and the voltage and the current in the resistor 1 we get 615.2 ampere, and so this our simulation result we get, and I will show you the graph. Okay, so after we run the simulation, we get our graph like this. Okay, so this is our graph for time domain transition with R load. Okay, after this I will show you the graph with R and inductance load. Okay, okay, so this is our result with RL load. So we get the voltage after the diode is negative 7.622 volt, and the current at after R1 we get 846.9 ampere, and is same to L1 load. The current will flow and go to the supply. So I will show you the graph with RL load. Okay, so this is our graph with RL load with time domain transient. So the graph will not same because it have time domain in the with 10 millisecond to 50 millisecond, and another that we have curve time domain is a number red, is a red color. You will see that the 30 millisecond to 35 millisecond. So this is our graph time domain RL with RL load. Okay, so that's all from us about lab 1.